All right, now we're going to take a look at our notes for adding and subtracting rational expressions. So let's take a look at what our directions are first. Similar to multiplying and dividing, our first step is to factor both denominators. So we want to make sure that our denominators are factored. Notice that I did not say numerator and denominator, I just said denominator. We're going to leave our numerators. We actually want them not to be factored. I know. So for adding and subtracting, we're going to be adding and subtracting those numerators, and so we need our denominators to be in factored form, but the numerators need to stay as they are. Then we need to determine a common denominator. This is usually going to happen by multiplying the denominators. I'll show you some cases where that's not the case, where it'll be easier to kind of look and see what's missing. But if we just have, like in our first example, we have two linear denominators, we're just going to multiply them. And then we're going to multiply by the missing factor, so what's not there, and then we are going to write as one fraction and add the numerators. So let's take a look at what I mean by that. So we have 3 over x plus 2 plus 5 over x plus 1. The first thing I want you to do, this is a linear factor. It can't be factored any further, so I'm going to go ahead and put parentheses around both of those. And now I'm going to go off to the side and I'm going to write down what my common denominator is. My common denominator needs to include both of these factors. And so what I'm going to do is I'm going to let my common denominator be x plus 2 multiplied by x plus 1. And so I'm going to go ahead and I'm going to rewrite both of these fractions. I'm going to say, well, this is going to be x plus 2 times x plus 1 plus x plus 2 times x plus 1. All right, and now we need to do the same thing that we did with our warm-up. So I'm going to go ahead and I'm going to look at this first fraction. It has the x plus 2, but it doesn't have the x plus 1, so I'm going to go ahead and multiply by x plus 1 over x plus 1, right? So that's how I get this expression in my denominator. Notice that now they match. So this is now going to be 3 times x plus 1. And then I'm going to do the same thing here. I have the x plus 1 from my common denominator, but I don't have the x plus 2, so I'm going to multiply by x plus 2 on the top and the bottom, or in the numerator and the denominator. So I have 5 multiplied by x plus 2. Now I'm going to go ahead and now I'm going to add these numerators, but I can't add them yet because I need to multiply out. So I need to go ahead and distribute, and so I have 3x plus 3 over x plus 2 times x plus 1 plus 5x plus 10 over x plus 2 times x plus 1. Now that it's in a form that I can combine like terms easily, I'm going to go ahead and combine my like terms. So I get 8x plus 13 all divided by x plus 2 times x plus 1. So once I have it in a way that I can, I'm going to add those numerators together. Just to see off on the side, you could also, if you liked solving these more vertically, you could also do that. So we could set up, so I'm going to do the same problem in a different way, and you can just kind of sit back and watch, or if you prefer setting them up vertically, you could watch it. You could copy this down for yourself. I'm going to write 3 over x plus 2 plus 5 over x plus 1. And now I have to do the same thing. I need a common denominator. And so my common denominator is going to be that x plus 2 times x plus 1. Because those are I need all the factors that are in the denominator, and so now I have all the factors that are in the denominator. And so I'm going to say, okay, well, this equals, and I have x plus 2 multiplied by x plus 1 equals x plus 2 times x plus 1. And now, again, what's missing is that x plus 1 factor. So I need to multiply, in order to get that x plus 1 down there, I would have to multiply this fraction by x plus 1 over x plus 1, because it already has that x plus 2. And we could do that right in here. We get 3x plus 3. And then same thing over here. I need to multiply this one now by what's missing. That's going to be that x plus 2. And when I distribute, I get 5x plus 10. And now since I have the same common denominator, I'm going to go ahead and add my numerators. I have 3x and 5x yields 8x. 3 plus 10 gives me 13. And then I have an x plus 2 multiplied by x plus 1. Same answer because it was the same problem, just done a different way. Let's try another one. Let's try number 1. So I'm going to set this one up vertically again because I think that might help some of us. So we have 5 over x plus 2 over x plus 1. All right, we need a common denominator. So x plus 1 is fully factored and x is fully factored. So x is one factor, and then the whole expression x plus 1 is another factor. So my common denominator is just going to be the product of these two factors. So it's going to be x multiplied by x plus 1. And so I'm going to go ahead and say equals x multiplied by x plus 1 equals x multiplied by x plus 1. And now I'm going to play the game. I'm going to say, all right, I have an x in this denominator right here, right? But I need an x times x plus 1. So this is my missing piece. So I need to multiply by my missing piece. I'm going to multiply by x plus 1 over x plus 1. When I do that, I do 5 times x, 5 times 1, so I get 5x plus 5. And do the same thing now with this function, or this expression. I have the x plus 1, that's a check, right? I have an x plus 1 and an x plus 1. What I don't have is this x. So I'm going to go ahead and I'm going to multiply by x over x. Because x divided by x is 1, right? So I'm just multiplying by 1. Not changing the value at all, I'm just making it look different. So I get 2x. And now since my denominators are in check, I can go ahead and just combine my like terms in the numerator. So I have a 5x plus a 2x, which yields 7x. I have a 5, and I have x times x plus 1. All right, let's do a subtraction. We're going to skip, hop, jump down to number 4. So in number 4, we have subtraction. I'm going to go ahead and I'm going to line, first I'm going to go ahead and factor this guy, right? Because everything else is good. This is linear. I'm going to go ahead and factor this one. So if I factor x squared plus 3x plus 2, it's a quadratic trinomial, so I know it will factor with 2 binomials. I'm going to do x times x, which gives me x squared. 2 multiplied by 1 gives me 2, and then 2 plus 1 is 3, so I'm good. And now here's what we're going to do. We need to find that common denominator. So let's start first by just rewriting this vertically. And if you do this horizontally instead, again, that's great. All right, now for this one, notice that I have an x plus 2 and I have an x plus 2, so that's awesome. They already share a common factor. But then this one has an x plus 1 and this one doesn't have an x plus 1. So my common denominator for this guy is going to be x plus 2 times x plus 1. I don't have to have 2 of those x plus 2's in there. I have it in both spots, so that's already common between both of them. And now I also need to have one with this x plus 1. So what I'm going to do is I'm going to go ahead and I'm going to just multiply this second one by x plus 1 so that it also has that factor in the denominator. And so this guy stayed the same. We have 6x plus 7 over x plus 2 multiplied by x plus 1. And now over here, I'm going to subtract, I'm going to distribute, and I get 3x subtract 3, plus 3 over, and I have x plus 1 times x plus 2. And here's where we just need to be really careful. So we're doing subtraction, right? So we're doing 6x subtract 3x, which gives me 3x. And then we're doing 7 subtract 3, which gives me 4. So just remind yourself to subtract all of the terms. So we get 3x plus 4 all over x plus 1 times x plus 2, and we're done. All right, here's what I want you to do. I want you to now pause the video, and I want you to try question number 2 and question number 3 with the people around you, and then you can play the video and check your answer. So maybe I'm gonna do my video is gonna be number 2 next, and then I'm gonna go to number 3. So it would be best for you to do number 2, check, see how you did, and then try number 3 and see how you did before moving into the practice. All right, so hopefully you took the time to pause and give yourself time to think through this and check your answer. Again, if you didn't do that, I highly recommend pushing pause right now, because if I just give you the answer, it's not gonna help you think through it at all. So again, I'm gonna line this up vertically. I see that this first one has a denominator of x minus 1. That's fully factored, I'm good. This second expression has a denominator of just 3, right? So that's fully factored. And so my common denominator needs to have a 3 in it, and it needs to have this x subtract 1 as a factor. So 3 times x subtract 1 is going to be my common denominator. So now I need to make both of these have that common denominator of 3 multiplied by x minus 1 in order to subtract them. So I'm going to go ahead and multiply this guy by what's missing. What's missing is this 3 over 3. I'm going to multiply this one by what's missing, and what's missing is the x plus 1. So now I can distribute, right? This is in parentheses, so it's 3 times x, 3 times 1, so I get 3x plus 3 in that numerator. And then we know that we're subtracting, so I'm going to make sure I carry that over. And then I have x times x, which gives me x squared, and x times 1, which gives me a positive x. And now, since I have the same common denominator, I can go ahead and add my numerators. So notice there's an x squared term here, but no x squared term up here. So all I have is a subtract x squared. Then I have a 3x subtract, so I have a 3x subtract x, which gives me 2x. And then I have a 3 with nothing to subtract from it, and we're done. We could take this one step further and factor the numerator, but we're not going to go there. We're just going to kind of live in this world of practicing this. So just as an extension for those of us that things are clicking, otherwise you can just fast forward till I get to number 3. We could factor out that negative. Because this is a quadratic trinomial, and then factor that numerator to, what would that be, x minus 3. Oh, it doesn't even do anything for us. Just to see if anything like simplifies further. But again, I am very, very happy if we get here and we're good to go. All right. All right, I hope you pause the video again and you are looking at this one. The first thing that and then you've already tried it, and now you're checking to see how you did. The first thing that I notice when I see this is I need to factor my denominators. This first denominator is fully factored with an x plus 1, so I'm good. This other denominator is a difference of squares, so I'm going to rewrite this one. We have 3 divided by x subtract 1, x plus 1, plus 5 over x plus 1. So what I notice is that I have an x plus 1 here and an x plus 1 there, so that's awesome. Done. This guy has an x minus 1, but this one doesn't. So I'm going to keep this one horizontal, just for those of us that are solving them, that are simplifying them that way. I'm going to go ahead and multiply by that x minus 1 over x minus 1 so that I can get that into the denominator. So now you'll notice that I have the same factors in the numerator and the denominator. I'm sorry, I have the same factors in both of my denominators. So I have 3 over x subtract 1, x plus 1, plus, and I'm going to go ahead and distribute, 5x subtract 5 over x plus 1, x subtract 1. And now I can combine my like terms. I have a 3 and a negative 5, so I have 5x subtract 2 all over x subtract 1, x plus 1. All right, I hope that helped. Again, we're going to do a couple practice problems, and then actually I'm going to have you do a couple practice problems on Delta Math, just so that you have that to reference. If you get stuck, you can use those videos. And then you are smooth sailing for the weekend. I look forward to seeing you guys all on Tuesday.